Hello students, in this question we have been given a parallelogram ABCD. E and F are the midpoints of sides AB and CD. E is the midpoint of AB, F is the midpoint of CD. It says show that the line segment AF and EC trisect the diagonal BD. Okay, so let's start the proof. E is the midpoint, right? E is the midpoint. We know that opposite sides are equal. Opposite sides of, we need to mention it, opposite sides are equal, so we can say AB must be equal to CD. Opposite sides of parallelogram, so their halves AB by 2 must be equal to CD by 2, and that means AE must be equal to FC. Here it is AE and FC must be equal. Also AB is parallel to DC, because this is a parallelogram, so opposite sides must be parallel. And if they are parallel, then AE is parallel to FC. So what we have collected here, the two opposite sides AE and FC are equal and parallel both. Therefore, AECF is a parallelogram. If it is a parallelogram, then we can say AF is parallel to EC, opposite sides of a parallelogram. Well, so now in triangle, CQD, F is the midpoint. F is the midpoint of DC, and FP is parallel to CQ, right? Because these two lines are parallel, so their parts should also be parallel. That means we can say here P is also a midpoint, of DQ by converse of midpoint theorem. And if P is the midpoint of DQ, that means we can write DP is equal to PQ. Therefore, DP equals PQ. This is our first equation. Now, in triangle, BAP. In this triangle, E is the midpoint. E is the midpoint of AB, and EQ is parallel to AP, because EC and AF were the opposite sides of this parallelogram, AECF. And if EC and AF are parallel lines, their parts EQ and AP should also be parallel. So what we have collected here is the midpoint from where a parallel line has been drawn to the second side AP. So this line must bisect the third side PB. Means Q is the midpoint of BP. Q is the midpoint of BP. Again the same reason, converse of BPT. Converse of BPT. Converse of midpoint theorem. Midpoint theorem. Well, that means PQ equals QB. This is our second equation. Now if we talk about the two equations, in the first equation we wrote dP equals PQ. Here dP equals PQ, and just now we have proved PQ equals QB. So dP equals PQ and PQ equals QB. So all these three parts are equal. From 1, 2 and 3, we can say dP equals PQ and PQ equals QB. All the three parts are same. That means if we take the ratio, that means let us equate all of them with x. Let us say all of them are equal to x. So the ratio dP is to PQ is to QB equals x is to x is to x, means 1 is to 1 is to 1. Trisect. Trisect means dividing in three equal parts. All these three parts are equal. All these three parts are equal. Thus, we can make a final statement that AF and EC, these two lines, because AF is intersecting the diagonal BD at P and EC is intersecting the diagonal BD at point Q. So AF and AC trisect the diagonal BD. So it is proved.